Good morning, students. Students, this lesson is of class 7th for the subject of physics. Topic: symbols and functions of various components of an electric circuit, which is covered in chapter 7, Electricity and Magnetism, of your textbook titled Concise Physics by Selena Publications, and is being submitted to you on 25th January 2021. So first topic for today is symbols and functions of various components. Now, students, before studying symbols and functions, let us know what is an electric circuit. An electric circuit is formed by a source of electricity connected to various electric components. So, as you can see that what is an electric circuit? In an electric circuit, we are having a source of electricity, and that source of electricity can be a cell or a battery. And further, we are having various electric components joined with the cell or a battery using conducting wires. Now all the equipments and components are joined by wires made up of a conducting material. These wires are also known as conducting wires, and usually they are made up of copper. Thus, we can define an electric circuit as an electric circuit is formed by source of electricity connected to various electric components. The basic electric components in an electric circuit are: firstly, we need a source of electricity. Secondly, we should have a switch or a key. Then we need a resistor. And the important thing, we need some connecting wires. So these are the four basic components required to make an electric circuit. Now students, let us study each component in detail. Firstly, we will be studying about source of electricity. A cell or a group of cells. Group of cells is also known as battery. So a cell or a group of cells is generally used as a source of electricity. A group of cells connected in series is called a battery. So what is a battery? A group of cells connected in series. Connected in series is called a battery. Students, as we have already studied the construction of a dry cell, and it is learned that a cell has two terminals, a positive terminal which is known as anode, and a negative terminal, which is known as cathode. So a cell has two terminals, a positive and a negative terminal. So in case of symbolic representation of a cell is represented by two vertical lines of unequal lengths. So how do we show a cell? A cell is shown by two vertical lines of unequal lengths. One is a taller line and the other is smaller one. The bigger line or the taller line represents the positive terminal of the cell, while the smaller line represents the negative terminal of the cell. To use two or more cells, the positive terminal of one cell is joined to the negative terminal of the other cell, and so on. This is called the series combination of cells. Students, we studied above that this combination in series of cells is known as battery. So if I have two cells and if I want to join them in series, I will be joining the negative terminal of the first cell with the positive terminal of the second cell. So here you can see a combination of two cells, and such a combination is known as series combination. And students, since we have joined two cells, so this is the symbolic representation of battery, where the two cells are connected in series. If you were having three cells, then the negative terminal of the second would have been joined with the positive terminal of the third cell. So now you can see three cells joined in series, and these three cells joined in series is collectively known as battery. Now let us move to the second component, that is a switch or a key. Now students, a switch or a key is used to put the circuit in an on and off state. That is, it is used to put the circuit on and off. Now you must have seen a switch in your home. If you switch on the light glows, while if you put the switch off, the tube light does not work. Why so? It is because an electric current does not flow through the circuit if the key is open. So if the key or a switch is open, then the electric current will not flow in the circuit, and thus the components in the electric circuit will not work. The symbolic representation of an open key is, you just have to make brackets. The bracket represents the open key. And if we put a dot inside the bracket, it represents a closed key. Open key means no current is flowing in the circuit. Closed key means current is flowing in the circuit. Similarly, the symbolic representation of an open switch is, it is a line, or you can say it is a latch which is opened. So the circuit is open as the circuit is incomplete. And closed switch means you have to put the latch down. If you put the latch down, then the wire or the circuit gets completed. Again, open switch represents no flow of electric current, while in case of closed switch, electric current flows through the circuit. Coming to the third part, that is a resistor. Students, a resistor is the component which opposes the flow of electric current in the circuit. Resistor opposes the flow of electric current in the circuit, and symbolically it is to be shown as shown to you in the diagram. So how to draw it? First of all, you will be using terminal wires, or between the two wires, what we will do? We have to draw the symbol of resistance. So first of all, the connecting wires, in the connecting wires, we show the resistor like this. It is in form of spikes. Okay, so this is the symbolic representation of a resistor. Further, we will be having connecting wires, and students, as told you earlier today, connecting wires are used to connect the various components in an electric circuit. What is a connecting wire? The wires which are used to connect the various components in an electric circuit. They are usually shown by solid lines. So, they are shown by solid lines and are made of conductors. Generally, we use a copper wire for making connecting wires, since copper is a good conductor and is also not so expensive, which can be afforded easily and is a good conductor of electricity. Now student, let us learn the new topic for today, that is direction of conventional current in a circuit. When the circuit is complete circuit means if there is no insulator inside the conductor, inside the circuit, and the circuit is complete when the key is on. So see, the key is on. It is a closed key. And in the circuit, I have taken a cell, one cell, and a closed key, and I have put an electrical appliance I have taken that appliance to be a bulb. Now students, the conventional current, the electric current in the circuit, in the conducting wires, flows from positive end of the cell or a battery to the negative terminal of the cell or the battery. So as you can see the arrows, the arrow represents the direction of electric current. It flows from positive terminal to the negative terminal of the cell. Now students, if there was open key or an open switch, suppose the key was open. Now in this case, there would have been no current flowing in the circuit. So in that case, you are not supposed to mark any arrow, since there is no current flowing in the circuit. If the circuit is open or if the key is open. So here what is happening? There is no key. The key is open. Open key means circuit is incomplete. And students, if electric current is not flowing, it means that the bulb will not glow. It will not glow since it is not receiving any electric current. But if you close the key, electric current will start flowing and the electric bulb will glow since the current is reaching to the appliance which is kept inside the circuit. Further, today we will learn about series and parallel circuits. So what is a series circuit? In a series connection, all the appliances are connected in series in such a manner that if any one appliance goes out of order, the rest of the appliances will also not operate because the circuit then becomes incomplete. Thus, it can be concluded that in a series circuit, the appliances in use are dependent upon each other. So let us understand series circuit by seeing figure number 1. In figure number 1, I have drawn a battery and you can see a closed switch. Since the switch is closed, the electric current will flow from positive terminal to negative terminal of the battery. And here in the series connection, students, I have drawn 3 appliances, that is appliance number 1, appliance number 2 and appliance number 3. Now suppose your appliance 2 is not working properly. This is not working. So what will happen? If this is not working, that means it will not allow the electric current to flow further. Now students see, current starts from battery, it goes to the appliance number 1 and then it reaches appliance 2, but from appliance 2, here electric current cannot flow further. So if the current is not reaching back to negative terminal, it means that the circuit is open circuit. Why open? Because it is an incomplete circuit. So in that case, no appliance will work. Appliance 3 is not getting current. Appliance 2 was faulty appliance, and since the circuit is incomplete, appliance 1 will also not work, though the current is reaching till appliance 1, but it will not work because the circuit is open. Why open? It can be represented by such way. Now the current is reaching in appliance 1 but not reaching to the negative end of the battery. So since circuit is open, no appliance will work. So what does it mean? That in series circuit, all the appliances are depending on each other. If one of the appliance is not working, then the other appliances will also not work properly, because the circuit will behave as an open circuit. Thus, we have said already this thing, that in a series circuit, the appliances in use are dependent on each other. The second type of circuit is parallel circuit. When the circuit is in parallel, all the appliances work independently. In parallel circuit, the appliances work independently, while in series circuit, all the appliances were dependent on each other. So in parallel circuit, every appliance when put on works on its own without the interruption of other appliances. Students, in our household wiring system, all the circuits are in parallel. Now, for further understanding of parallel circuits, let us study figure number 2, which is drawn on page number 4 of the PDF sent to you on 25th January 2021. Now students, in figure number 2, again I have taken a battery and a closed switch, while I have taken 3 appliances connected in parallel manner. So students, when the current starts flowing from the positive end of the battery and reaches to the intersection point, then the current gets divided. Now students, see, at the intersection point of the connecting wires, the current is having 2 ways. It can go up also, and it can go towards right to the appliance number 3. So what happens here? Since there are 2 wires, the current gets divided into 2 ways, or you can say the current gets parted in the 2 directions. Again, after reaching the second intersection point, current gets divided into 2 parts. So I have taken current I1 to be flowing in third appliance, I2 in second appliance, I3 in first appliance. This I1, I2, I3 is just the number of the different amount of current flowing in the circuit. So we can study it with example also. Suppose we are having 20 ampere of current coming through the battery, 20 ampere, and this is 20 ampere. So suppose I1 is 10 ampere. That means further we are having 10 ampere current. This can happen that 8 ampere current is going through second appliance such that only 2 ampere will go in appliance 1 because this was 10 ampere current. 10 ampere current gets divided into 8 and 2. So I3 is 2 ampere, I2 is 8 ampere and I1 was 10 ampere. Now all these currents when reaching on the negative terminal of the battery will again become 20 ampere. So students, what can we say? If our first appliance is not working properly, second and third appliances are still getting the respective amount of current. What does it mean? It means that if our first appliance is not working, students, still appliance number 3 is working because it is connected with positive terminal of the battery and negative terminal of the battery. So the circuit is closed for appliance 3. Similarly, if we see appliance 2, it is also connected with positive and negative end of the battery. So for second appliance also, the circuit is closed. Only appliance 1 will not work, since for that the circuit is open. So what is happening here? If one of the appliances is not working, the other appliances will work. There will be no trouble in the working of other appliances connected in parallel. So it can be said that in parallel circuit, the appliances are not depending on each other and are working independently. So with this, I come to an end of this interactive session. Students, you all are requested to go through the given notes again and understand the concepts taught today. Thank you, students, and have a nice day.